if you want to know about the properties of these p block elements, these p block elements are mostly non-metals. S block elements are metals, but p block elements are mostly non-metals, and they form maximum covalent compounds. Nitrogen produce covalent compounds, oxygen produce covalent compounds because they contain covalent bond. You know, water is one compound of oxygen, ammonia is one compound of nitrogen, and in this molecule they contain covalent bond, and that is why they form covalent compounds. So mostly they form covalent compounds, and they are bad conductor of electricity, and they have the tendency to gain electron. S block elements have the tendency to release electron, and these p block elements have the tendency to gain electron. So these are the main properties of p block elements. Now we will move to number 3, that is called d block elements. So what are d block elements? The elements in which the last electron enters in any one of the d orbital, of their respective penultimate cell are called d block elements. I will tell you what is penultimate cell. So in the electronic configuration, if the last electron enters in d orbital, then they are called d block elements. In modern periodic table, group number 3 to group number 12 contain d block elements. These elements are also called transition metals. This is very important. Transition metals, because their properties are in midway between S and p block elements. So you know, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This group contain these transition elements, I mean d block elements. For example, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the example of other elements I have not written. So down the group, these are also called transition metal or d block elements. So if you want to write their electronic configuration, for example, scandium, its atomic number is 21. Already you have written the configuration: argon, then 4s2, then 3d1. If you want to write electronic configuration of chromium, 24, argon, then 4s2, then 3d4, 24 atomic number, I mean 24 electrons. And to make it stable, one electron come from s to d, so it becomes 3d5, 4s1. If you want to write the electronic configuration of zinc, zinc is 30, argon, then 4s2, then 3d10, total 30. So these are the electronic configuration of these transition metals, and here you have seen the last electron always enters in D. After filling 4s, you have to enter in D, and since the last electron enters in D, That's why they belongs to D block elements. And you know, here this group number 3 to 12, as you know, group number 1 and 2 they contain S block, and group number 13 to 18 they contain P block. I mean the D block elements are present in the middle position of the periodic table. Left side contain S block, right side contain P block, and in the middle position they contain D block elements. And when you study the properties of the elements, as you know, the properties always going on changing in a period. I mean, when you study the properties from left to right, the property of the element either going on increasing or going on decreasing, and that is called the periodic properties. Since the D block elements are present in the middle position, left side S, right side P, and since they are present in middle position, that is why their properties are somewhat similar with S and somewhat similar with P also. So since their properties are in midway between S block and P block, and that is why they are called transition metals. So that is one point. And secondly, here you have seen, you know, 4S, it is present in fourth cell, and 3D, it is present in third cell. I mean, it is present in N cell, it is present in M cell. So when you enter the last electron, here N cell is the valence cell, I mean outermost cell is called the valence cell, but the last electron is not entered in valence cell. Last electron is entered in M cell, I mean before the valence cell. So that is why, suppose this is nucleus, this is your first cell, this is your second cell, this is your third cell, and this is suppose fourth cell. This is called L, K, this is called L, this is called M, and this is called N cell. Here valence cell is N, but the last electron enters in M cell. The outermost cell, this is called valence cell. And the next one is called penultimate cell. Penultimate cell. And next one is called anti-penultimate cell. Anti-penultimate cell. And these are called inner cells. I mean, the outermost one is called valence cell, next one is called penultimate cell, the next one is called anti-penultimate cell, and the inner orbital, inner cells, they are called simply inner cells because they are present inside the atom. Now here the last electron is not entered in valence cell, I mean outermost cell. The last electron is entered in penultimate cell. That's why I have written the elements in which the last electron enters in any one of the d orbital of their respective penultimate cell are called d block elements. So in case of d block elements, the last electron do not enter in valence cell, they always enter in penultimate cell. And here you have seen, when you write the valence cell electronic configuration of these elements, for scandium you have to write 3d14s2, for chromium you have to write 3d54s1, and for zinc you have to write 3d104s2. So when you write the general electronic configuration, they contain one s and one d orbital. The valence cell if you mention as ns, then penultimate cell you have to mention as n-1, because if it is 4s it will be 3d, if it is 5s it will be 4d. And what about the electron? Your s contain maybe 2 electron, maybe 1 electron, and in some cases it may be 0, and that is why you have to write 0 to 2. One of the element called palladium, you will get S0. So that is why you have to write 0 to 2, and in D it may contain 1 to 10 electron, and this is called general valence cell electronic configuration. General valence cell electronic configuration for d block elements. So this is very important. What is the general valence cell electronic configuration of d block elements? Then you have to write n-1 d 1 to 10, ns 0 to 2. This is very important for example for d block elements. So thank you for today.